Uni-Gal by Colleman Corporation, and this is electrometer picoamperes. It says on left hand side is short, then I have Pico 17, Pico 1100, S17, S1100 direct. I don't know yet what it means. This is a contribution from local university to the science. Basically, it was penny that I paid for it, and this one was made by Colleman. If I short these two leads, it's gonna stop. It's stopping at a certain location. We need to go to zero with that, but before we do it, I'm gonna show you how this thing is done. You have a mirror in here that is simply flipping, and this is the heart of it, and the contact here. Now on the top, when I put that back, oh boy, I have to first stop it. Which is normal position that the electrometer should be at. Then I adjust that, and then when I turn the handle, I'm able to adjust zero. The original scale is missing, so I'm not able to show you a zero, but you see the reaction on it. This stuff was somewhere in the basement of the university, and this capacitor was in charge for approximately 30 years, maybe 35 years. Okay, and we're gonna try with that capacitor. So what I'm gonna do is I put the scale in here maximum, and I'm gonna, now it's a little bit moving, but I'm gonna connect like that. We have a capacitor in, and now I'm gonna touch it and see what's happened. Okay, it went all the way up. When I release it, it's gonna bounce. Now I'm gonna decrease the range. Now it looks like I'm almost fitting within the range, and I'm gonna decrease the range again. No reaction. So now it looks like no reaction. Not much. And I'm gonna go to the maximum again. Okay. I'm in maximum again. It looks like a part of the charge was already discharged, because now electrometer is slowly coming back. So it looks like this capacitor is discharged. Now I put that capacitor to a little bit more modern device, which is WinKer Precision Magnetic Analyzer PMA 3260A. I'm gonna find out what is the capacitance of it, as I barely am able to read what is there. Okay, so we're talking about 149 microfarads, and the resistance is 32.7 milliohm. Well, actually, it's a good question. Are we talking about resistance or are we talking about impedance? Because it's AC measurement, supposed to be. But let's go to Z. Now we have 39.1 milliohm minus 33.1 degrees in phase. And when we try to find out what is the inductance of that capacitor, we have a minus 67.8 nanohenry, which minus stands about degrees in out of phase. Q, and the Q is 0.648, still minus 67 nanohenry, and then we go to C, 150 microfarad. So this capacitor was not really holding the charge, but charging itself in pico amperes. I was able to measure the charge that still exists. Okay, we see vacuum capacitor. The vacuum capacitor moved a little when I touch the wire. Okay, now I have a coil connected. This one is made by Central Scientific. And it's division of Shonka Instruments Corporation. It looks like we have two coils, one in here and the other one over there. I connected this coil to electrometer, and I'm gonna use the magnet and see if we have any movement. First I put the magnet like that. Now I'm gonna flip it. Nothing happened. Now I'm gonna put it like that, and then you see that while I'm moving magnet, I'm creating a charge. Current, very little current in the coil. The strange thing is that when I stop the magnet, the charge should not be there, there is no capacitance here. It's inductance, although the coil by itself might have a capacitance, but mostly to the impedance value, not to the DC current. Okay, I remove that, and again I put it back. Okay, while I'm changing an angle, you see electrometer reacting. It's a good question, why? I have a static field, so in the time of the movement I can create a current, but then it looks like based on me changing the angle, the electrometer is changing the position. I'm gonna show it to you again, like that. I flip that one way, and I flip that second way. Again, left, right, left, right, left, right. Just a simple experiment. We have another electrometer in here, which is Emdeco Shonka Electrometer. It does have a calibration, selection, and adjustments. Shonka is connected to a probe, and the probe has a viewing part of it. We may not be able to see properly, but I'm trying to do my best. Okay. This is what I'm regulating right now. There is a scale. I don't know if it's visible, but I can have a needle on it. What is the secret? The secret is here. You can always stop the frame and read what is here, just for saving the time, skipping reading it.